Thank you, Chairman. My name is Yuto HORIOKA from Shinshu University, Japan. Today, I will talk about a topic entitled A Crawling Robot that utilizes propagation of deformation waves of a bistable lattice actuated by a single motor. This is a robot which is producing crawling locomotion driven by one servo motor on a curved rail. I would like to explain why and how we built this. Firstly, I will talk about our motivation of this study. Secondly, I will explain how to fabricate a robot. Thirdly, I will show you the locomotion experiment. Finally, I will conclude the talk and talk about the future work a little bit. In this research, we develop a mechanism that can propagate waves even when the body is bent, and we apply the propagation to develop a robot that can perform crawling locomotion along a curved branch. Here, I will emphasize two unique points of this study. Point 1 is bistable structure with energy difference in two stable states we use in the robot. Point 2 is installing method of bistable structures makes the body bendable. Let me explain point 1. There are two types of bistable structures: bistable structure without energy difference and bistable structure with energy difference. Both of them have pro and con. Bistable structure without energy difference can propagate wave repeatedly, but waves tend to stop. By contrast, bistable structures with energy difference can propagate wave easily, but only once. We alleviate the con by adding reset mechanism. In previous studies on wave propagation, both ends of bistable structures are fixed to the wall, which cannot accommodate bending. In this study, we propose a spline for bistable structure to be fixed on to allow for bending. This is a prototype we built. I will explain in the following slides. Let me explain a bistable structure in our prototype. A PP film was cut and nicked like the crease pattern diagram with laser machine. It was folded and glued to be a origami structure. The two lengths of the structures L1 and L2 were not same, so it was asymmetry. The center movie is two origami structure attached to a beam. It was stable in right side because of its asymmetry. When we added a thread, constrained the distance of the two origami structures, bistable structure with a lower energy on the right side was complete. Now, we are going to connect these bistable structures. As shown in the left figure, the bistable structures were glued to a flexible beam and connected the springs so that it could propagate the waves. When we attach the bistable structures across the beam for bending body and attach it to the springs diagonally for wave propagation, even when the body was bent. Next, we will move on to the reset and wave propagating mechanism. A single servo motor attached to the back of the prototype realizes reset, and wave generation. When the motor rotates and the reset thread is pulled, all bistable structures are pulled by the thread to transition to high-energy stable states and can be reset. When the motor rotates reversely, the rearmost bistable structure is pushed forward through the spring. From there, all the bistable structures transitions in turn and propagate waves. The last part is how the legs move for glowing locomotion. The trajectories of leg tips differ between while resetting and propagating. When the bistable structures reset because of thread tensions, the leg tips travel inside and continue to grip the rail. On the other hand, when the bistable structures propagate waves, the leg tips travel outside, so they release the rail once and re-grip the front of the rail. These repetitions enable the prototype to locomote with a single motor. Now, let me show you the locomotion experiment. These are videos and graphs of locomotion experiments on straight rail and curved rail. The horizontal axis of the graph shows the time and the vertical axis shows the distance traveled along the rails. On both the straight rail and the curved rail, the prototype succeeds in propagating waves and locomotion. The position marked with marker at the head of the prototype beam advanced when the reset was performed. Experiments were conducted on a sloped rail with two different stop times. Please see a lower left graph, which shows how the servo motor moved. The horizontal axis of the graph is time and the vertical axis is servo motor's angle. The servo motor was controlled to stop for stop time 8 seconds in high energy stable states and for stop time L seconds in low energy stable states. When the stop time H was 1 second, the distance read during wave propagating was larger than the distance forward during reset and the prototype slid down. However, when the stop time H was 15 seconds, we observed the wave propagate slowly. The prototype climbed up because the left leg released the rail at once and the gripping force was improved. Okay, let me summarize the presentation. We created the mechanism that can propagate waves repeatedly by a single motor. The mechanism that propagates waves along a curved body and succeed in locomotion on straight, curved, and inclined rails. In the future, we will improve the mechanism so that it can climb steeper inclined rails and change direction, not only horizontally but also vertically. Thank you for listening.